good afternoon, everyone. I appreciate you taking time out.
Your connection is not really stable, but yeah, we can go through it. So,
okay.
So welcome everyone to this final session for today. It's a workshop. It's a workshop improving 3D site characterization, driving innovation that improves 3D rendering of natural and man-made environments. So who will be presenting first?
Okay, Marco. This is John, and I want to welcome everybody here this afternoon for this meeting. Like everyone on this call, I'm hoping everybody's enjoyed the previous sessions and the ability to have an opportunity to learn a lot about the innovations and advancements that are occurring in this Web 3 community. Inherently, we are making a lot of great strides in areas of research, development, and publishing. And I've been really impressed with the diversity of topics that have been discussed up till now, as well as all the concerted efforts across the community to enhance and improve the way we're visualizing different types of models and features in the web. So with that said, one of the challenges inherently we're dealing with is that we find ourselves in a world right now where inherently we're able to start collecting data and three-dimensional data in a variety of ways that we probably had thought about just a few years ago. It's amazing in my mind right now. I can take my iPhone, my Apple, and basically right now go out and actually collect LiDAR data of an image. You think about some of the other broader applications and discussions earlier in the at this meeting with regards to metaverse and how advancements in VR and AR capabilities are taking place. Advancements in photogrammetry, advancements in bathymetry, sonar data. It's just, we're finding ways to collect man-made and natural features in a way that we haven't done in generations. And while it's exciting, it inherently has some of the challenges. And so this workshop has kind of evolved from the time it was initially submitted, because as we began discussing with different users of X3D as well as other applications, it became apparent that we need to be thinking about how an X3D domain or other domains are being used by our clients or being used by the community as a whole, and being promoted in a way that inherently is getting the maximum value on the web, and it's truly extensible. So from this standpoint, our interest here was to begin basically using a couple of users as a mechanism to kind of facilitate discussion. Because what we're ending up dealing with is, while normally a want here has been to pull data together of a similar type and to be able to use that data in a way to create models, inherently we're finding ourselves using data sets from different sources and several data formats. Examples are CAD, Revit, GIS. In that case, one has to manage merging this diverse material into a uniform representation of the environment. And X3D has shown that it can work there, but we also have realized that we do have some challenges with the ability to easily convert to X3D. We have challenges working seamlessly with other programs like Builder, like MeshLab, like a variety of other platforms. And rather than spend a lot of time just developing and just laying out the different challenges that users are having. I wanted this workshop to kind of focus on some applied guidance and kind of use case scenarios to illustrate some of the challenges that different individuals are having. In this case, we're using two individuals that are very familiar to our community. One is a colleague of ours, Feist, from Swift River Environmental. Swift River is a small 8A small business that is providing a variety of remote sensing and 3D modeling applications to a variety of clients. And another one is Alex, who's actually listed as a co-presenter for this workshop. And Alex is intended to present some of the cases, at least one in particular case, of some of the challenges pulling together a variety of different data sets at a very large scale and trying to make that seem extensible to the environment. And my hope here is by showing these use cases, it will facilitate towards the end of our workshop here some discussions about where we as a community need to find ways to better support individuals like this and help find ways to overcome some of the challenges that they're facing. With that said, Luke, do you mind if I let you share your screen with the team and let you kind of dive in? Luke, are you there?
Sure. Did you want to push the slides
there
there from the other side? Yep. Testing. Comm check.
Hello.
Testing.
Yes, I'm doing. Yep.
Okay. John, can you hear me?
Just tell me when to go on.
That's an interesting way to put it. So it says.
Yeah, look, I can hear you.
I haven't seen it pop up yet. So. Oh, there we go.
Yes, I can.
Now I'm getting the internet unstable message. Okay, here we go. All right, so the background of my presentation is going to focus on the OODA loop. So there's the title slide.
All right.
Go ahead and go next slide, please. Is my okay? I'm good with this. Next slide, if you can, please.
This is the first slide. Yeah.
Hello, testing.
Okay.
Okay, there we go. Thank you. All right, so for those of you who are not familiar with the concept of the OODA loop, thanks, Don. Oh, I'm sorry.
Yeah, look, it's you're there.
Okay. I feel like I may have like a very substantial lag through this system here, so apologies. Perfect. Okay, so here's the OODA loop, and this was created, in the Air Force to support fighter jet dogfights, right? And the basic concept is, okay, observe, orient, decide, and act. And the faster you can complete that loop to where you act and then observe the results of your actions, reorient to the new observations, decide what to do next, and act again, the faster and the tighter you can create that OODA loop, the better off you are going to be, the more informed you're going to be, the better decisions you're going to make, and the more effective your actions will be. And inside the context of the fighter pilots, the faster they could act, the more disconnected they could make their opponents or their adversaries from reality. I think, some folks would argue, hey, this is kind of outdated. I disagree. I think the OODA loop is more relevant than ever in the 21st century. A lot of, if not all of my projects right now are connected to the US Department of Defense, who is struggling mightily with a innovation challenge, I guess I will say. So why is that? I would argue it's because the Department of Defense has allowed themselves to be out OODA looped, right? The world is moving faster than the department can observe and orient to. So before they get to a decision point, the world changes. And then they have to re-observe, reorient, and then figure out what they're going to do. And by the time that happens, the world changes again, right? And in the context of this brief, we're going to look at primarily some base laydown and some installation resilience issues in context of climate change and sea level rise. So next slide, please. Looking for slide 3, I think. Thank you. Okay, so this is a little bit of a visual representation of the OODA loop, and you can see there. And so, I've already talked about that first bullet a little bit. Hey, the faster we can do this stuff, the more effective we're going to be. And in order to do it right, we need to leverage the things that we've already got, right? So if we need to develop a new tool, well, that takes its own amount of time. But if we already have these large existing databases, these systems, tools, everything, like how do we maximize the efficiency and the effect of those tools in a fast and consistent manner? And the second bullet there really talks about, hey, as we move into the 21st century, a lot of folks did this 20 years ago, but some of us are still catching up. The people who win are going to be the folks who can aggregate and synthesize these data sets and really put the right information together at the right time, understand what all that information means, right? When we say orient, that really means understand, right? How does what I see relate to what is real, right? Like the jet pilot concept, hey, the adversary plane is flying south. Well, so what, right? Flying south doesn't mean anything until I put the orientation that, hey, I'm flying south. Okay, am I in front of or behind them? Or if I'm flying north, do I need to turn around? So, okay, we're going to orient to that data, then make decisions, act, and re-execute our OODA loop. So, as we said, the folks who can synthesize, aggregate this data, figure out what the information is that can be brought from that data, they're the folks who are going to win and get out ahead of their adversaries. So next slide, please. Okay, so how does this all apply to anything that we're doing in the world of X3D? So what we've been doing here is we've partnered with our government folks, are primarily NAVFAC, the Naval Facilities Engineering Command, and we've developed some stuff along with some partners that are on this conference as well, and tried to develop new tactics, techniques, and procedures, TTPs. Sorry, I'm distracted by the chat. The new TTPs to basically move this faster, right? Like, hey, we know it's big and it's slow to go out and collect these data sets, to go out and digitize the real world in order to be able to make real world decisions in a digital environment. So, hey, how do we go about doing that faster? How do we go about making that data more reliable, right? Do I know that, hey, if I scan this building and it says it's 10 meters tall, how do I know that it's not 10.2 meters tall or 11? How do I trust that data that we're getting? And then how do I use that data to really make decisions? How do I present that data in a way that your lay user can understand and appreciate? And then how do you put it in decision makers' hands to inform the decisions that they really need to make in order to affect the changes that the departments and the end users actually need? Make sure I'm still on track here. So yeah, let's go next slide. Okay, so what's getting in the way here? And as I'll point out here in the next couple of slides, there's a handful of barriers to what I would call successful integration of the data into a usable end product. And again, I'm focused at the lay user level, not your power users, not your developers. How does a salty old Navy captain make a decision in the 21st century when they're used to typing in all capital letters because it makes the file size smaller and they can send it to a submarine? So hey, in a world of big data, how do I get these folks who are very averse to big data to make decisions based on it? So one of the biggest ones, and John already talked about this, is the disparate sources, right? Like, where is this data originated at? Is it LiDAR? Is it photogrammetry? Is it Revit or any 3D CAD models? Is it older than that? Are there navigational charts that we're using? Are there topographic maps? Are there hydrology? Is there bathymetry? The lack of clear insights. Okay, so we put it all together. What's it mean? Like when 1 + 1, does it always equal 2 in this environment? I would say not always. Scalability has been a large challenge as we say, okay, well, I can do one facility, I can do one block, I can do 1 acre, I can do a base. Can I do a state? Can I do the whole planet? At what point does this become too much? And where is that sweet spot as far as, okay, this is what the technology can support. This is what keeps a model usable. How do we scale the size, the data, the quality of these models that we use such that they are the most effective? And then, the complexity involved in predictability. This is, when you actually get down into the decision-making process. Again, this is a 1 + 1, what's it equal type thing. If we're talking shore resilience, is it as easy as making a taller berm or a better seawall? Or, is the flooding that we may experience caused more by rain than the sea level rise, and now we've just trapped the rain even more? So how do we make these decisions in a complex and changing environment? Next slide, please. Okay, so I'm going to go through just a quick kind of case study that we've done, and I'm not going to say it out loud, but if you have seen a map or been to a vacation spot, you may recognize some of the pictures I use. So what are we doing? What we've done is we have created a visualization tool to basically allow folks to collaborate real time and live and work inside of this modeled, almost a virtual twin. And I think when Alex follows me up here, he will show you a much better virtual twin, where we can do things like change the environment to show what we're looking at. And I'll show you here in a couple slides, but hey, if we're looking at sea level rise, well, okay, let's model the environment. Let's show where the sea level's at now, and then let's raise the sea level and see what happens. And what we get from that is it allows us to make some decisions about where our risks are. What do we lose from flooding? What gets, what are the impacts of nature changing? And then what are the impacts of the mitigation strategies that we choose to execute? So, I think it's only the early innings of this technology, obviously, as we get further and further along into the 5G and Web 3D and Internet of Things, right? As the world goes meta, so to speak, we're in early innings of this, and I think it's all on the same path, that it's all going to improve. That, I guess it's a apt analogy here, that a rising tide will raise all boats in this matter. There you go. That's absolutely true, William. Next slide, please. Now I'll stop throwing words at you, I think. Okay. So here we're looking at this case study here being just a large scale waterfront infrastructure, right? And as you can see, there's a whole lot of shoreline right there. There's a whole lot of very key infrastructure and a whole lot of stuff that A, was really expensive to build, B, will be next to impossible to replace if it's lost. So this needs to be protected and is of immense strategic importance. So, hey, losing this is a non-starter, and degrading its capability is almost just as bad. So how do we maintain the capabilities of this environment, of this facility, of all the infrastructure associated with it, when we know, right, that the sea levels are going to rise and it's going to have an impact here? And then not only that, like, hey, if we try and attack that problem via a 3D virtual environment or a digital twin, what else can we get from that? Can we get some other benefits from that? And then, so I talked about some of the challenges we've had. So you can see, just by looking at, I'll say the picture on the bottom right there, where, okay, what data sets will we have here, right? Obviously, we've got some overhead imagery. We've got terrain maps. We've got some navigational charts with bathymetry. And you start overlaying some of this data. And what's it tell you? It's really hard to go from all these individual sources of data into an informed decision, right? If I know where the floods, right, the watershed's going to funnel water in this area, right? This area is lower than that area. Okay, so I can get some general ideas. But it doesn't really tell me that I'm going to lose the building right there on the end of the pier. Right, I really have to guess at that. So if we move into a better model, next slide, please. And here I'll talk about a little bit of the X3D stuff that we're using. So we've chosen to go through and create this virtual environment in the X3D, built on X3D, right? And largely because of the reasons associated here. It's extensible, it's cheap, royalty free. Like we're not paying the Esris of the world to maintain all this stuff for us. And we can do a whole lot with it. Next slide, please. And so this is what we've called it. It's Spiders 3D. It's specialized infrastructure data repository. Alex will go into a little bit more on this. But inside of this, we've built a whole bunch of models of real world stuff like weapons platforms, facilities, support equipment, forklifts, trucks. We've got, sailors that you can put into scenes. And it allows us to do visualization and collaboration in real time, right? We can create these storyboards and show and demonstrate alternatives. It's like, okay, if this, then that. And it allows us to iterate, right? And we can kind of run OODA loops in a virtual environment, right? Like we can reach 100 years into the future or 100 days or 100 minutes into the future and see what happens. And oh, by the way, due to the things that we get out of the X3D platform, I can put a bunch of users in this, and they can use really low-end computers. Like the average Department of Defense computer is not very powerful. They can get on through a web browser, collaborate in a scene with folks across the planet, and they can all speak the same language and see the same things at the same scene, which is incredibly powerful for the types of uses. Next slide, please. For the types of stuff that we're talking about. Okay, so here's just kind of a little bit of a visual representation of what I just said. So we're taking these 3D models, right, and these all coming from different acquisition strategies, I guess. You know, we've got designs from the manufacturers of some of these weapons platforms, whether that's an aircraft, a submarine, a surface vessel, or a facility, and we can import those in and convert them to X3D models. And so John talked a little bit about this in his lead-in is, hey, if that process was easier, that would make this whole thing a whole lot easier. Right now, that's a bit of our crunch right now is transferring that data, right? Converting that data from whatever native format it is into X3D. Once it's in X3D, we upload it to our catalog, and now we can pretty much drag and drop it into our scenes. So once it's converted into X3D, it becomes very powerful for us. But getting it to that stage so far has been a very large chunk of the work. And then now once we've got it, we can render these scenes and manipulate these scenes and use them as a very powerful collaborative tool. And then we can keep iterating. So next slide, please. Pretty sure. Next slide. You can see how complicated this gets when you start talking about, hey, you know, how to orient yourself to that scene. So, okay, we digitized it. We created this fairly detailed virtual environment here that, you know, they're missing quite a few ships, but we've got those ships in the inventory of the system, and we can put whatever type of ship you want in this scene. If you want to pull aircraft carriers next to the pier, if you want to put tugboats, if you want to put rubber raiding craft, we can drop them all into this scene and show you what it's going to look like. And from that, you can orient yourself to the scene a little bit and say, hey, I hadn't thought of this. You know, how do we get 5,000 sailors on and off the prow of this aircraft carrier? So there's different things you can walk through. And I talked a little bit about, hey, what are the second layer benefits of a system like this? You know, we created this to show you the image on the right. Hey, if the sea level comes up 2 feet, what's it look like? Well, hey, that whole pier there on the left side of the picture is flooded. Right? There's water everywhere. That's no bueno. And another benefit that we've gained out of this is the ability to use, hey, this virtual environment that we've created. If the systems acquisition folks are trying to develop these new weapons platforms, right? If they're whether it's a new aircraft carrier or a new submarine or new unmanned systems, they have these very difficult challenges of where are they going to put this stuff, right? You see how busy. Go back one slide, please. Right? Hey, I'm the Navy. I'm going to spend $1 billion on a new ship. Where are they going to put it? And they struggle very mightily with those sorts of basing decisions on where can I have the capacity to store this stuff. what are the capabilities of these piers and these wharfs and the harbor itself? Can they do what they think they want to do? And in the past, it was really difficult for them to make those decisions. But what we're finding right now, go forward 2 slides, please, is that since we built these models in a couple different places, they become very powerful for the use of planning. Where are these acquisition folks going to put stuff? And then this is back to the resilience. Okay, so we can play with the sea level rise, right? At 4 meters, bad things really happen, right? That's what, 12, 13 feet of water. Like that's going to be a problem. One more slide. And due to some of these models, right, we've got the detailed insides, like we can see actually where the water is going to be inside some of these buildings. Hey, what do you lose? What do we need to protect? Can we afford to lose the inside of this, that bottom left picture, right? If that's full of sensitive equipment, hard to replace equipment, well, that's a bad day, right? If it's full of trucks that can be moved easily, if it starts raining or if the seas are coming up, okay, like we can move those. So they can make those sorts of risk decisions. And I think that's my last slide. Push one more, please. Yep. Okay. So, oh, okay. That's weird. All right. So there's the findings, I guess, from some of our work to date. But really, what I'll try and leave the group here with is how can we make this onboarding process of this data, the conversion, and then the manipulation of the data once it's inside of the X3D environment. How can we make that easier? How can we make that more usable by your average person who's not going to be in there every day, who needs to go in, visualize something, manipulate that environment to whatever need they have, make a decision, and then leave, right? And then come back maybe the next day or the next year, and use that tool to their benefit. So how can we make that easier? At the developer level, anything is possible, right? But at the level of the folks who have never used these tools before, how can I make that better for them? I'm sure many folks in this event have used virtual reality or augmented reality stuff before, but holy cow, when that stuff works, it is really powerful. So if we can get something like these models into a virtual environment or a representative, there are no human, there we go. So how can we make this more powerful? And I think AR, VR is going to be a big one, and Alex will show you some stuff here shortly. But that's where I'll leave it, is, hey, how do we make this better? And I don't necessarily think it's better technology at this point. It's going to be better usability of the technology. And I'll kick it back to you on that, John. If there's any questions, I suppose we can look at those quick.
Okay, so thank you, Luke. I really do appreciate you rolling things out. Alex, if you don't mind, I just need you to just do a brief introduction of your challenges, and if you mind showing your slides, I'd appreciate it.
So the other set of slides.
Yes, please. So Alex and I are sitting next to each other, so you will see some sorcery and just like that.
Mm-hmm.
All right, Alex, make your first slides up.
Okay, awesome. Thank you. So build on Luke's presentation. We're going to get another use case in terms of looking at how we use Next3D to, again, integrate lots of disparate data, be able to contextualize and be able to provide a bit more of a shared insight. What we're going to show here is, the challenges we're seeing is, again, how do we now take that X3 data? How do we enable presentation, enable users to interact with the data? So not so much the back end, but maybe just the front end of how folks experience the X3D and some of the challenge we have that kind of we're living with in the military in terms of trying to implement that capability. Certainly we see X3D as a great, affordable, sustainable technology. So what hopefully we'll show you is that those capabilities being delivered, and talk a little about some of the challenges we go forward to again provide that interactivity. Next slide, please. Just a quick what's driving us here. Obviously, there's probably similar drivers, and not just the military, but in the business world. We just need to be able to move faster, be agile, be able to communicate a much faster, more robust construct than we have in the past. With the emergence of digital engineering, data strategies, using virtual environments really is kind of a key pillar of how we can deliver that data to consume through visual communications, and be able to leverage investments that we have in quite a bit of data and unlock and be able to maximize the value. Next slide, please. Common themes. I think Luke touched on these things. Is again, OODA Loop. Well, that is trying to kind of. So it's a one voice. How do we do this collectively? We've got lots of investments in different tools and data. We really need to take advantage and maximize those capabilities to the extent we can to create a common operating picture to really inform a lot of diverse decisions across planning, engineering, and what we'll show you is, Navy and NAVFAC, we have working with our industry and the Web3 consortium, a lot of partners develop a capability that begins to show the power of the technology and start allowing us to really exercise the OODA Loop. Next slide, please. All right. So yeah, I think probably this slide is maybe I'll say preaching to the choir a bit. A lot of goodness with the technology that we've been experiencing in Web3D. The really one of the key capabilities that we're hoping to continue to leverage is the real-time network communication aspect. As COVID has really forced societies to kind of be dispersed, and the ability to really kind of engage face-to-face, have those in-person discussions and meetings getting a lot harder. So connecting real-time across time and distance so that we can learn fast and overcome those challenges of time and distance. Really, we're pretty excited about the potential we have at hand. And the fact that Web3D is a well-established technology, very stable, really is technology that can permeate across all aspects of our business practices and use cases. Next slide, please. So we're going to just kind of step through a kind of a specific project exemplar, just to kind of show really the kind of the scope and the breadth and the depth of all the different data sets that we are trying to integrate and distill into X3D to develop these web-enabled virtual environments. As you can see, we're starting with a pretty large size, over 2 terabytes of data of again, just very disparate data sets. Lots of different formats, different fidelities, different capture methods. So this is a good example of how we begin to take large dispersed data sets and start to really optimize down into a common X3 format. Next slide, please. So for this project, just here are quite a number of data, I'll say metrics, give you a sense of the scale that we are working with. Just, I guess I won't belay this slide too much. There's just a lot going on in terms of just different data sets, the amount of area that we're trying to visualize, the disparate types of infrastructure. We're going to show in this example the ability to, again, create an environment that we can now present different alternatives of future sea level rise. Really, I think the takeaway here is at the bottom is the accuracy. This is really getting towards a geometrical, geospatially accurate digital twin of a very large installation that will enable us to do a lot of collaboration with. And again, that's with, that's aerial, that's undersea, terrestrial. So quite a bit of information in a very accurate rendition here. Next slide, please. Again, here's just a list of the different sources of data we're working with. Again, photogrammetry, LiDAR, sonar, CAD-based models. As you saw the previous slides, kind of the native data set starting at over 2 terabytes. As we begin to mesh and optimize the data sets, we're now, vastly, major magnitudes of reduction in some of the file render size, and again the need to reduce the file data sizes. We're, as Luke indicated, we're working with very low end computers, very basic hardware capabilities, and so the ability to take this massive data sets and be able to run on these base computers with very limited constricted network bandwidth really is a key to the success of our efforts here. Next slide, please. Just to kind of highlight the transformations of the data sources. What are we transforming in terms of the geospatial qualities and really the end products, right? So the end product is, again, a web-based virtual environment that will have some level of user interactivity, allow users to interact with different data sets overlaid onto the virtual environment to provide that insight and understanding of the complexities of the installation. Next slide, please. Okay, so I'm just going to show us a short video here of the installation. As you can see, there's toggling, which is bringing forth new data sets. We have vegetation, we've got infrastructure. So again, the ability to toggle data on and off to provide unique presentation perspectives, be able to really allow users to focus on those key elements that need to be discussed. This scene is got, again, as we indicated, quite a number of different features. As you can see, the level of fidelity in terms of the infrastructure down to individual components. We've got the ability to present users with an environment that has a range of elevations from minus 17 meters to 32 meters. So again, the Z value that can be shown. That's hard typically with a lot of different tools. We're able to really present that well and allow users to have a very good confidence in what they're seeing. All right, next slide. I have to hit the next slide again. There we go. And as I think Luke and John indicated also, the ability to really kind of take the data to the next level, immerse users in the data, provide a much more visual and haptic experience to understand the complexities of when we provide alternatives to do different infrastructure elements. Now we can put folks in a much better viewpoint, immerse them in a perspective that provides the insights that we typically don't get in traditional 2D projections or even static 3D projections. Again, the ability to leverage X3D and its simplicity in terms of leveraging HTML and JavaScript, be able to deliver this just through a basic web browser is fairly powerful. And then, now bringing in other data sets so that we can start to evolve to a construct where we can integrate on a kind of a more efficient iterative basis, whether it's new hydrological models, weather, buoy, data feeds, bring in different models of weapon systems and buildings infrastructure. So this will be a foundation that allows to really kind of start interchanging these data sets on an easier basis and present at large scale. Next slide, please. So here's another short video. We have Dr. Paulus is kind enough to render a 3D virtual environment in Immersion there at Virginia Tech. And just to provide the ability that we're experiencing with the technology to bring stakeholders into an immersive environment they've never had before. And the ability to have those shared insights, reach consensus on decisions. We see this type of immersive capability to meet the future acceleration of utilities, right? So we can start having multiple visionaries or caves being able to render across the time and distance.
Alex, we're having a little bit of issue with your audio.
Okay, I'm sorry, there's audio and video, yeah.
Video's fine, audio is where we've lost you.
Those of you want to just go to the next slide. Next slide, please. Okay, and now just a quick interface. So this is kind of, as we've been talking leading up to, is I think we've really understood well how to leverage X3D to instill a lot of these data sets. Show you this is a very basic example of an interface. And this is probably the challenge that we're seeking to help us is how do we really, what are the tools, how do we quickly enable users to develop interfaces that can support a wide variety of data consumption. So as you can see here, we simply have some toggles so that we can present different layers of data. So again, this is an opportunity for us to feedback from the community to see if there's how can we do this on a more easy basis to create these interfaces to render and publish the data.
Okay, Alex.
Hey, Alex.
Yeah, we're gonna.
Go ahead, John.
We're gonna probably need to just ask you to stop there. If you want to just show your next slide, because I think it's a good one to end
That's the
on.
last.
But yeah. So yeah, you're just coming us so Gramble, we just can't hear you. So we're going to end there. I want to thank you and Luke for it. Everybody, obviously, due to technical issues and a little delay, we ate up a little bit more time than we anticipated with our session today. I think the thing that I want to allow you all the opportunity to do is to kind of understand some of the use cases from an applied standpoint that those out there working with X3D are inherently having. The chat exchange has really brought up some really interesting questions. I do appreciate people putting a couple of questions into chat, because these are the intent here with this workshop was not necessarily a want to necessarily generate solutions. It was not necessarily a want to emphasize patches or different approaches that we can end up taking. Inherently, the want of this workshop was to create a thought exercise. They want to inherently create a mechanism that we began to think about to go a little bit further than we have with regards to go beyond the aspect of the code to understand how do we find ways that we are ensuring that the domain has the best value proposition possible, and that the domain is not just having a value proposition within the X3D community, but we're having an opportunity to realize how the domain is being utilized and potentially has value proposition to our peers in places like OGC, et cetera. Inherently, as we're dealing with this want to integrate disparate data set from a variety of different locations, and that we're looking at them at fine scales and broad scales, and we're looking at human dimension elements, and we're looking at cultural resource elements, and we're looking at issues with regards to challenges geospatially. I think the thing that we're looking at is that inherently within our community, within the X3D consortium, that we've got to find ways to work across even our own working groups to find ways that we're finding ways to be a lot more applied in the way that we're thinking in an applied mindset for how the domain is going to bring greatest value to the community as a whole. So inherently, with what limited time we have left, which is about 5 minutes, I appreciate people throwing comments into the chat. If anybody has any other comments or any questions that they want to throw out to the team as a whole, or you want to have further engagement, please feel free. This is a good time to just take 5 minutes out and kind of talk about things. And Don, it looks like looking at your video, you're biting at the bit. So please feel free to go ahead and jump in here.
Well, let me just take the baton from you, John, and say that this exemplar, I hope nobody, John, I think it's your video that's showing right now. Is that correct?
John,
maybe
you're
we
muted.
can maybe we can show both. I hope it's coming across. This exemplar is, it's kind of, I put something in the chat. It's kind of like an industrial use case, but more general, more public. Here we have public works, we have land and sea, we have, there are coastlines all around the world with cities and capabilities. And besides business as usual, we're wondering, well, what does climate change do? How do we respond to that? What places are most vulnerable? How do we fix that? New York City got religion over a decade ago and strengthened Lower Manhattan because they were flooding out. They were shorting out Manhattan. Gee, there's an imperative. I think that it's really cool. It's not just a demo, but I saw you guys in action in the past. How you didn't have to do the demo. You just gave it to people, and then they started saying, well, look at this, what about that? And maybe we should. So I'm really jazzed by what you're showing, not just for the stellar 3D of Annapolis, but for the collaboration possibilities. And I think that's something nobody else can do right now. Over.
And Don, I think you've made a good point. I don't think that, the value proposition, as you pointed out, is not just in the fact that from a generalization that we're focusing on a topic like coastal resilience. The issue here in my mind was inherently by pushing these generalities up, was to begin to thinking about all the different ways we're using X3D and how X3D has a broader proposition. I mean, inherently, the reason why we're getting traction in this community right now is inherently because it is open source, non-proprietary. It ends up becoming a bridge that inherently right now the community is looking for. It needs this type of tool and extensibility to be able to really be able to get the most value out of the data that it has. And that's what we're talking about here. How do we maximize data? And how do we integrate disparate data from numerous different sources? And from our standpoint, it's one of those things where we can do that and we can show greater value proposition if we work on thinking about how do we improve our converters and how do we end up allowing people to move easily from different softwares to different softwares, and how X3D can help improve that. It gets into issues about ways of us basically ensuring that, as understanding that there is so much advancement in the community that we within the Web3D consortium cannot end up doing this by ourselves. And we ourselves need to work more collaboratively internally and work more collaboratively with different other partners and stakeholders that have inherently an interest in 3D on the web. These are things that I think we need to find ways that we're thinking about. So as I say, the intent here wasn't necessarily to wow anybody. It wasn't necessarily to focus on coastal resilience. It was to try to get us to begin thinking about where we as a community need to begin thinking about understanding things are changing and we need to make sure that the domain is evolving with those changes. Okay?
Yeah, and let the record show New York City was not able to do what you just said until the water started flooding over the low seawall and filling up the subways and shorting out the electrical junctions. And so I think you're posing something of very broad value, public value, and very important interest. Thanks.
All right. Well, thank you all. It's the hour's come and gone. I'm hoping everybody, if nothing else, as they say, our want here was to create just a thought exercise and let us all begin kind of thinking about how we want to see things proceed. I want to wish everybody a wonderful afternoon. I want to thank Marco and everybody for an amazing job of keeping things running and on time and on schedule and keeping things organized. We really appreciate it. And inherently, we're looking forward to the next few days and to obviously learn and talk about other applications and to dive further into the research and development and publishing. And I look forward to participating in those discussions. But I'm hoping that this thought exercise early in the process will help kind of formulate some of those discussions going down the road. So everybody have a wonderful day. I'm glad to see we had the opportunity in the second day. Wish you all the best. Thank you all.
Thanks, everybody. Appreciate it.
Thanks.
So thank you everyone that participated in this session. If well, the discussion may go on the OODA channel, and thank you all that attended today, and see you tomorrow at the tomorrow morning and at 9. Thank you very much, and have a nice evening or whatever time it is at your place.
There will be an evening before tomorrow.